Hi, my name is Hyeon-Woo. Today, I will talk about scratching visual transformers back with uniform attention. This work is collaborated with Kim Yoo-ji, Byung-ho, Dong-Yun-han, Song-Jun-oh, and Tae-Hyun-oh. Firstly, I will give the summary of this work. We observe that VIT prefer the dance interactions, but there exists learning difficulty from softmax. It indicates the strong preference of dance interactions, so we introduce simple and effective module context broadcasting for infusing dance interactions. This module reduces the burden of dance interaction of attention. Transformer is proposed in NLP. It's been extended to computer vision and has potential to multimodal understanding. This favorable performance is attributed to no limitation of interaction range due to self-attention mechanism. We will focus on vision transformer. We can categorize the spatial interactions as shown in figure. The first is long-range and dense interactions. The second is long-range and sparse interactions. And the third is local range and sparse interactions. Previous work have focused on the property of long-range interactions. In this work, we explore the density to understand the attention mechanism. How can we measure the density? Attention is normalized by softmax, so the values are calibrated into probability. We use the definition of entropy. High entropy means the distribution is close to the uniform distribution, high density. Low entropy means the distribution is close to sparse, low density. The left figure is the entropy values of the learned attention. We observe that the average values of entropies are high. 50% counting values are much close to dense attention, which means the interactions are close to the uniform interactions. However, learning dense attention is difficult to learn because of steepest gradient value around the dense interactions. It indicates the strong preference of dense attention against softmax. We propose the context broadcasting module. This module infuses dense interaction to VIT. The reason why we introduced the module is no additional parameters, computation efficiency, and one-line code. By experimentally, we locate the CV module to the end of the MLP block, but CV module improved the performance regardless of the position. What does CV affect VIT? CV decreases the attention density. Since low entropy means the sparse interactions, CV makes the attention sparse. We also observe that the change is prominent in higher layers rather than lower layers. When we insert the CV module to higher layers, CV improves the performance more than applying CV to all layers. The CV changes the long-range interactions. We measure the relative distance, which is the interaction distance. We can see no change of long-range interaction. Therefore, the favorable property of long-range dependency is preserved. And we conduct ablation study by changing the number of heads in multi-head self-attention. Our module is more effective in fewer attention heads. We evaluate our module on robustness benchmark. CV improved the robustness. Also, our module improved the segmentation performance. Right figure is the visualization of attention maps. VIT focus on non-object region. By infusing dense interactions, you can make attention focus on more informative spatial region. The last but not least, I will give summary again. We observe that VIT prefer the dense interactions, but there exists learning difficulty from softmax. So, we introduce simple and effective module for infusing dense interactions. This module reduces the burden of dense interaction of attention.